Welcome to another simple and easy applied stats video, brought to you by Significant Results. My name is AJ, and today I will be showing you how to check the assumptions before conducting an independent t-test using SPSS Syntax. If you have watched my previous videos on how to open SPSS Syntax, retrieve data using SPSS Syntax, and even how to conduct descriptive statistics using SPSS Syntax, then you should be pretty much caught up and be very familiar with the syntax that I have here. This first syntax is to get my data. This second syntax is to format the dependent variable, basically remove the number of values after the decimal. This syntax is to add values to my independent variable, rather labels. This syntax is to split file. This is to conduct descriptive statistics, and this is to take the split file off. I discussed these in my other videos, so if you are curious about how to split file and run descriptive statistics, please check out my other videos. Now, for the point of this video, we're going to look at 6 assumptions that need to be met before you conduct an independent t-test. Now, I'm not going to go too much into detail about these assumptions, but what I will say that if you violate these assumptions, your results of your independent t-test may not be valid, and more importantly, you can make inferences using your results, which is kind of the main thing of conducting statistics. So the first assumption is to have a continuous dependent variable. For my data set, I do have one. It's lies. So that's a ratio variable. So when I talk about continuous dependent variable, we're talking about ratio, interval, and sometimes in rare cases ordinal. Now the second assumption is that my categorical independent variable has to have at least 2 levels, and it does because I'm looking at political party, Democrats versus Republican. When I talk about categorical independent variables, I'm talking about nominal variables. The third assumption that needs to be met, and probably the most imperative one, is independence of observations. So when we talk about that, we are mentioning that we're not doing any pre-post tests, so the person or people on the first measurement are not measured again. In my example, or with my data set, what I'm saying is that the people who identify as Democrats are not saying they're Republicans and lying, and people who are Republicans are not saying they're Democrats and lying. So the two groups that I'm looking at, Republicans and Democrats, are different and do not cross over to influence the measure of the dependent variable. The fourth assumption is no significant outliers, because outliers could impact your mean, and since this test looks at means, we don't want any singular value to increase or decrease your mean. The fifth is approximately normal distribution of your dependent variable for each group. So your dependent variable should be approximately normally distributed for Republicans and Democrats. In my example, violations of that could impact the interpretation of your results. Since we're trying to make an assumption or an inference of the population, which is approximately normally distributed, your group should also follow that same distribution. And the last assumption is the homogeneity of variance between your two groups. So you don't want to compare groups that are, one, that are not representable about the population, at least a distribution about the population, and two, when you have two groups that differ in their variances, that could impact the results, because you may have one group that has more extreme values at the ends of the tails versus another group that doesn't. And when you have those extreme values, you increase the likelihood of outliers, which could impact your averages and your inference. Okay, so let's go to the syntax. So the syntax that I have here is to examine variables. My dependent variable lies is going to be analyzed by the independent variable party. I'm going to ask for some box plots, which are used for your outliers. I'm going to compare between the groups. I'm going to do some descriptive statistics, some confidence intervals. If there are any missing values, we'll do a list-wise deletion. And that should be it. Now, going back to the 6 assumptions, we already have these first 3. At least for my data, I have these first 3. As I mentioned, I have a continuous dependent variable, so check for that. I have a categorical independent variable, so that's a check for that. And I know that my groups have not crossed over into each other's parties by any means, so each group is independent of their observation. So let's run this. Okay, so this is my output from the syntax, and the first thing we get are our 2 groups, Republicans and Democrats. We get the number of individuals per group. There's no missing values at all. And then we get a bunch of descriptive statistics. So the things I want you to focus on, because this can be a little intimidating, it's a lot of values, a lot of different terms, is to focus on the means, because we're interested in the means, the standard error, and as you can see, they're very similar. Our means are very similar, our standard errors are very similar. Let's go to our test of normality. Now, there's a lot of debate on whether you should use your KS test or SW tests. Some people say that the Shapiro-Wilk is much more powerful in its assumption. As you can see, they differ in value. So to understand what this means, or what this means to you, is that you don't want your significant value to be less than 0.05, as we see here. I know that traditionally we've taught that 0.05 is great, but for this test, we don't want it to be less than 0.05, because what happens is, with this test, it generates a normal distribution curve. And then it compares that normal distribution curve to the distribution curve for each of your levels of your independent variable. Going back, we want to have an approximate normally distributed distribution for each group. That's assumption 5. So for assumption 5, as we can see that for Democrats, we have a normally distributed bell curve, or that our values our dependent variables are normally distributed for Democrats, but not for Republicans. So when I do my videos, I try to put situations that are very relevant and that are very real. I don't like to create data that's very clean, because honestly, I've been doing this for about, 8 years, and I rarely see nicely distributed data. So I want to use an example that's more relevant and probably more real to the data you collect. So going back to this, as we can see that this is slightly less than 0.05. So there's an issue with the distribution of the dependent variable for Republicans. So what happens when you do this case? Well, there's a couple of things you can do. You could transform your data. You could inspect outliers. There could be a lot of reasons why this is. But since I know my data, I know that those are not the issue. In fact, we can go down here, you can see that there are no outliers for Republicans, but we'll talk about this assumption in a little bit. Going back up here. So in addition to using this test of normality to determine whether your dependent variable is normally distributed, what you can do is use your QQ plots. So your QQ plots basically plot what your values are to what a normal distribution value would look like. That's an easy way of saying that. And as values, these little observations here, as these values need to be distributed across this line because that would represent our normal distribution. So what you can do is use two pieces of information to judge whether your dependent variable is normally distributed. And the first thing is to use this and then this. So as you can see, this violates the normal distribution of your dependent variable on Republican, but you can use this visual graph as evidence to say, well, there is some departure of values, but all in all, it does align on your QQ plot. So what I would do is I would say that my variable, specifically Republicans, their distribution is normal. Here is what the QQ plot looks for Democrats. You see, there's some similarity there, except for a couple values, but I wouldn't say that that would be a reason to say that this is not normally distributed. Okay. My next assumption, let's look at outliers. So, as you can see, there are no outliers for Republicans at all. There are a couple for Democrats, but they're not very extreme. And because I have a very low sample size as it is, I really don't want to remove any data because these could be actual data points. So we'll just leave them there. But in the case that you do have extreme outliers, then you may have to remove these extreme values, or you may have to transform your data. And that's another topic we can talk about in a different video. Okay, my next assumption is the homogeneity of variance. Okay, so even though this syntax provides a wealth of information, quite a bit actually, it doesn't include the assumption test for homogeneity of variance. What you have to do there is actually conduct the t-test. So we're not going to talk about the results of the t-test yet. That will be for my next video, but we need to conduct it to test that assumption. So I just ran it. Okay. So let's not focus on this part. We'll just focus on this area right here. All right. So you can see it's a Levine's test of equality of variances. So what that is doing is basically conducting almost like a t-test within a t-test. And the t-test that is analyzing is the difference between the two groups and seeing if their variances differ. And as you can see that the sig is above 0.05, which is good. Again, I know it's a little difficult because we're so used to wanting our p-value to be less than 0.05, but again, this is a different test in the sense that we're just seeing if they're different, and we don't want them to be different. So this is a good value that is 0.799, and that's saying that the variances between the two groups are not statistically different. In the case that it was, then we will be using this bottom section to interpret our independent t-test results. Similar to the results you write up when you conduct an independent t-test or regression or correlation, you also have to write up the results of your assumptions test. This will provide the reader an idea of, one, that you conducted assumptions, but two, what you were willing to accept in order for them to replicate if they want to get the same results as you have. So I discussed the box plots, and I talked about the outliers that were found. I also gave the reader a reason of why I kept the outliers, which were due to sample size, and also that my outliers were not extreme. I discussed how I determined that the levels for each of the parties were normally distributed, and I told them what I used, which were the QQ plots. So in case someone tries to rerun this and finds and looks at the normality test and see that the Republicans were not normally distributed, they can refer to the QQ plots and see why I determined that. And then I also report the Levine's test for equality. Specifically, I give the p-value that was found on the output, letting people know that there is not a statistically significant difference between the two groups in the form of their homogeneity of variance. So again, the purpose of this is for your reader to understand that you have done your due diligence prior to conducting independent t-tests in this case, and also answer any questions if they were wondering why you did this and not that.